This is called quadratic and linear systems. So what you have here.
Oh yeah, I got it. Was it 25th?
Yeah,
2 days ago.
This is a quadratic, 3x squared plus 5x minus 4. This is a linear system, 2x plus 5. I can tell by looking at the power of the leading variable, and the power of this one is technically the power of 1. That's how you let it know it's a linear, but we just don't write it in. It's not too important to write. We leave that blank. So what this question is asking us for is, where do they intersect? So I have some parabola, and looking in standard form, I know I got a y-intercept of -4. That's all I really got, though. And this one has a y-intercept of +5, goes up. It does something, so it probably crosses somewhere here-ish and somewhere here-ish. That's what we're trying to find out. Where do they intersect each other? So if you remember linear systems, to solve them, you set them equal to each other. So that's what we're going to start with. We're going to set these two equal to each other, because where they're equal is where their 2 points cross. All the other points aren't the same. Like here and here, those aren't the same. But where they cross each other, they're the same. So we'll take 3x squared plus 5x minus 4, and we're going to set it equal to 2x plus 5. Okay? Now this looks confusing. When we go to solve things, we actually want it to be set equal to 0. So we're going to move all of this to the other side and then collect like terms. So when we do that, we'll still have 3x squared plus 5x minus 4 on the left-hand side. And then when we move the other two terms, we'll have -2x and -5 are equal to 0. Okay, so we've moved everything from the right-hand side so that we have a 0 here.
Okay, and if this 5 was -5, then it would be +5.
That's
right?
absolutely right. Okay. Now we're going to collect like terms. So I look around here, I look for like terms, 3x squared. It's by itself. It's the only one. Okay. 5x, I got a -2x. Oh, that red didn't work out too well. And -4 and -5. Okay. So we collect our like terms. 3x squared stays the same. +5x minus 2x is going to give us 3x. -4 minus 5 is going to give us -9 equals 0. Okay. Now I have another kind of quadratic looking thing.
Yeah.
I can either factor, and I'm looking off the top of my head, 27. I'm not sure my factoring is going to work out. In other words, it's probably not whole numbers. Okay? So whenever I'm unsure and I got to find the values of x, I can use a quadratic formula. So x is equal to our -b plus or minus the root of b squared minus 4ac. I'll put a little square root here. All of that divided by 2a. Okay? And if you recall, this is my a value, so I'm going to replace these a's with that.
Yeah.
This is my b value, so I'm going to replace my b's with that. And this is my c value. Get down.
Go down.
And that's going to be the c value there. So we're going to plug in and then hopefully get two x values here. And that will tell us the x values of what we're working with.
Yeah.
So when we plug in, we get -3 plus or minus the square root of 3. Whoops, that's the wrong button there. 3 squared minus 4 times my a value is 3 and my c value is -9.
And this b right here is in brackets, right?
Yeah, I kind of put it like this, but absolutely. That b should be like that. That one should be like that. So that's multiplication, okay? And then all of that is over 2a. And our a value, again, was still the number 3. So now what we're going to do is we're going to simplify. X is equal, still have -3 plus or minus, and we still have our square root. I'm going to try to simplify it as best as we can. 3 squared is 9, so that's going to be 9. And then we have a negative times a positive is a negative. And then that negative times a negative is a positive. So we're going to get plus, which is good. Now I just got to figure out the terms. This is going to be 12 and 9.
Quick question. Say if this was a -3, -9.
Yeah.
Then what?
We had a negative times a negative times a negative. We would have had a negative value.
It would be a negative.
Yeah. And then in the end, we might end up with a negative under a root, which means there would be no answer to this. Because we can't square root our negative. Yeah, absolutely. Okay, so we get 108 here when we multiply that. So plus 108, and then all of that is over the number 6. So we're going to go down. Okay. x is equal to negative 3 plus or minus, that's going to be root 117, which I don't know what the answer to that is. That's going to be some decimal value.
Let me get my calculator.
Yeah, it'll be a little less than 11. So I'm going to say approximately 10.7 maybe. Give me get a calculator.
Yeah.
I think that'll be the root. But you double check it there. What I'll do is when you get that calculator is this is when we split. We're going to get two answers here. Okay? And one of them's going to say x is equal to negative 3.
3 to the power 3.
Yeah, they just reduced it. They didn't give it to us as a decimal, which is fine. We can work with it as a radical.
Oh, yeah, 10.81.
81. Okay, so that was close. 10.81. There we go, approximately. We'll get x is equal to negative 3 plus, I'm going to say about 10.81, okay, divided by 6. And the other answer is x equals negative 3. Whoa, what happened there? Put that back. Negative 3 minus 10.81 over 6. When I work that out, that's going to be 7.81 over 6. X is approximately, I don't know, 1.3-ish, I think. And then the other one, we're going to get negative 13.81 divided by 6. X is approximately negative 2.3-ish, I think. Are those about right?
The first one's right. The second one, let's say, negative 13.81.
Yeah.
Divided by 6. Negative 2.3, yeah.
Good. All right. Good estimating by me. So one of the answers, one of the x values is at negative 2.3. So that's where it intersects. And the other one was at positive 1. So my graph isn't perfect here. And those are the x values. So to actually get the true coordinates, because those are the x values, we still don't know what the y values are. We're going to take the linear equation. That's the easiest one to work with. Oh, nice. And we're going to plug in those x values. I could plug it into the quadratic, but that's a lot of work. There's more terms to deal with.
Yeah.
What's nice is it got this really simple linear. So we're going to plug in two versions of it. We're going to say when g is at 1.3, we get 2 times 1.3. Hi, honey. Oh, you got one too? Nice. Okay. And the other version will be when g is at negative 2.3. And these are going to give us our y values when we work them out.
Is this y equals mx plus b?
Yeah, it is. It is. We just put it in function notation. That's the only difference.
What does that mean?
It's when we use the f at x. I use the letter g because it's technically different than this one. It's like giving it a name. So we name everything we do when we do function notation. So this one here is going to become 2.6 plus 5, which is going to be 7.6. That's the y value. So that means one of the coordinates is 1.3 and 7.6. This one's going to be negative 4.6 plus 5, which is going to be 1.4. So the other coordinate is negative 2.3 and 1.4. So here are our points of intersection, which is a heck of a lot of work.
Daddy, can you see a cut on my head?
A little one. Oh,
That's myself in the car.